Hi, so in this video I'm going to explain a topic that we're going to cover in much more detail later on in the course called complex numbers, but it's something that we need to make solutions for second order differential equations. And what it is in short is, how do you solve a quadratic when the discriminant is less than 0? So if I was to quickly prove that to you, we can do discriminant b squared minus 4ac, where a is 1, b is 2 and c is 10. So we get 2 squared minus 4 times 1 times 10, which is 4 minus 40, which is negative 36. And if you remember from nat 5, that means that we would describe it as having no real roots, okay? But that does mean that it has imaginary roots or complex roots, and we can now deal with that in advanced higher. And the way that we deal with that is that we allow negative 1 to equal I squared, I being an imaginary number. And this allows us to get complex roots of the form p plus or minus qi, where p and q are constants. Okay? So in order to do that, you're going to need to know your quadratic formula, which I will remind you as being x equals negative b plus or minus the square root of the discriminant all over 2a. So for this particular case, we now know the discriminant is negative 36, so we do x equals negative 2 plus or minus the square root of negative 36 all over 2 times 1. So x equals negative 2 plus or minus, with I squared equaling negative 1 now, we can do 36 I squared over 2, which gives us negative 2 plus or minus 6I over 2, which then will give us negative 1 plus or minus 3I. They come in pairs because you've got the negative 1 plus 3I and the negative 1 minus 3I. There's much more theory behind it, but for the concept of differential equations and solving them, all we need to know is how to solve a quadratic to result in its complex roots. Okay, so I'll do 3 quick examples using that information. So again, we've got x squared minus 4x plus 5. So why don't we just find the discriminant, see if we need to use it. So we get negative 4 squared minus 4 times 1 times 5 equals 16 minus 20 equals negative 4. So we are going to need to have complex roots. So we get x equal to negative b plus or minus the discriminant all over 2 times a. So x equals 4 plus or minus 4I squared all over 2. So x equals 4 plus or minus 2I over 2. So x equals 4 plus or minus, x equals 2 plus or minus 1I, which we can just write as I. Do another one. B squared minus 4ac. So we get negative 2 squared minus 4 times 1 times 5, which is 4 minus 20, which is negative 16. So we do need complex roots. So we get x equals negative b plus or minus the square root of the discriminant all over 2 times a. So we get 2 plus or minus square root of 16I squared all over 2. So we get x equal to 2 plus or minus 4I over 2, which gives us the complex roots of 1 plus or minus 2I. Last one, b squared minus 4ac gives us negative 10 squared minus 4 times 1 times 26 equals 100. Minus 4 times 26, 4 times 25 is 100, so 4 times 26 is 104, equals negative 4. And so x will equal negative 10 plus or minus the square root of negative 4 all over 2 times a. So we get 10 plus or minus 4i squared all over 2. So we get 10 plus or minus 5i over 2, which will give us the complex roots of 5 plus or minus 5 over 2i. Like I said, we'll go into more detail about that later on in the course, but for the means of differential equations, that's all we need to know, and I'll explain that when we come to needing that in differential equations.